Hi guys, I am out for the day, but here we're going to work a little bit on percent yield. I'm going to show you a couple of ways to do some of the problems, and you guys can practice them in your book and you can practice them on your packet. So we're going to get started. So percent yield is really a comparison between what you theoretically could find and what you might actually find in the lab. So the formula for percent yield is your actual yield, something you might find doing an experiment or kind of just going through and doing some kind of a setup. It's what are you actually seeing in front of you? What are you actually getting for your values? And then the theoretical is what you're going to calculate. And then all percents, right, are a comparison between the two. And then in order to get it in percent, not in decimal mode, you have to multiply it by 100. Okay? So in your book, these are on pages 324 through 326. So I'm just going to work on a couple of the example problems in the book, just walk you through it, and then maybe give you like an additional example because the books are pretty straightforward and we can make this a little bit more difficult. So maybe they'll do a practice problem, and then what you can do then is you can finish your problems in your book, you can finish the problems in the packet. Tomorrow there's going to be a quiz on limiting and excess reagents, not percent yield. And then there's a couple pre-lab questions. The lab that we're doing tomorrow has both percent yield and limiting and excess reagent in it. So, all right. So let's do example problem 9.9 on page 325. It says methanol can be produced by the reaction between carbon monoxide and hydrogen. So carbon monoxide and hydrogen produces methanol. So we're going to write out that equation. The book gives it to you. If we balance it, we've got 2 hydrogen plus 1 carbon monoxide yields methanol, which is an alcohol. So the question says, suppose 68.5 kilograms or 6.85 times 10 to the 4th grams of carbon monoxide is reacted with 8.60 kilograms or 8.60 times 10 to the 3rd grams of hydrogen. Calculate the theoretical yield of methanol. So theoretical yield is always going to be doing some kind of stoichiometry problem. In this case, what the problem did was it gave you both reactants, and it's saying, hey, well, which one are you going to end up producing? And ultimately, what you want to try to figure is, what is the amount of product that you're going to produce, okay? So you can go through the work and figure out the theoretical amount of methanol that's produced. So we've got 6.85 times 10 to the 4th grams of carbon monoxide. So we can calculate the grams of methanol. So you just go through the stoichiometry problem and you have to figure out theoretically how much methanol is produced. And if I'm given both reactants, both the methanol and the hydrogen, I have to figure out which one's limiting me, and that would be the amount then that is used to find the amount of methanol. Okay, so if I go through the work, carbon monoxide is 12 plus 16, so this is about 28 grams. Using the balanced chemical equation, I have 1 mole of carbon monoxide is used to form 1 mole of methanol. And then if I do 1 mole of methanol, it weighs roughly 12 plus 4 hydrogen, so carbon is 12, there's 4 hydrogen, each one's about 1, you're at 16, 16 plus 16, this is about 32 grams. Okay, so if you do that work, we can figure out how much methanol is produced from that one. So you put that in your calculator. And then we can solve for the amount of hydrogen and how much that how much methanol the hydrogen produces. So about 2 grams of hydrogen, because each one is 1, roughly. I'm just estimating, just to make life a little bit easier. For every 2 moles of hydrogen, notice I'm still in the hydrogen mode, I form 1 mole of methanol. So again, we're just doing a stoichiometry to calculate which is my limiting and which is my excess reagent. And then this is still about that 32 grams that we found up there. Okay, so if you get the values for both of those, we can figure out which one is limiting and which one's excess. Okay, what you should have found is that this is about 7.83 times 10 to the 4th. That looks sloppy. Sorry. I can't make that thing go away. So this is 7.83 times 10 to the 4th, or 78,000 roughly grams of methanol that's produced if I react all of the carbon monoxide. If I react all of the hydrogen, I produce about almost 69,000, so 6.88 times 10 to the 4th grams of methanol. So hopefully that's what you got. So the limiting reactant is hydrogen. So hydrogen is my limiting reactant. So ultimately, this value here is going to tell me about my theoretical yield of methanol. Now, let's just backtrack a little bit. If I have these 2 reactants, carbon monoxide and hydrogen, and I have given amounts for each, I had to find out the mass of methanol that's produced. The problem says, okay, what is the percent yield? Well, theoretically, if I react all of the hydrogen and I don't have any problems in my lab, I should make 6.88 times 10 to the 4th, which is really tough to see. I am very sorry. Grams of methanol. That's your theoretical yield. That's if nothing was wrong. But the question tells me that 3.57 times 10 to the 4th, or 35,700 grams of methanol was actually produced in the lab. So there's a percentage here, right? So you're going to take the actual, the 3.57 times 10 to the 4th grams of methanol, and divide it by, theoretically, if nothing went wrong in the lab, oops, I wrote the wrong number. The 6.88 times 10 to the 4th grams of methanol. And that's right now a ratio of actual. So this is right now we have actual versus theoretical. That's just a ratio. If I multiply that by 100, I can actually get the percentage. And so the final percentage of your percent yield, your theoretical, your actual minus your actual divided by your theoretical is, or should be, 52%. Okay. So that's how you would solve a percent yield problem. In fact, we're going to be doing this in the lab. We're going to use copper 2 chloride and aluminum wire, and we're going to produce a product, and then we're going to look at, well, how much did we actually get? And through stoichiometry, how much should we theoretically have gotten? And that's going to be kind of what we do in the lab. So this is one way to do a percent yield problem. Typically, you have to be given the actual because that has to be done in an experiment, or you would have to be given your percent and your theoretical in order to find your actual. There really is no way to calculate actual unless you're given your percent yield and your theoretical. You can't do it through stoichiometry. That's something that had to happen in some kind of a lab experiment. So I'm going to show you a problem in which you had to calculate the actual mass that was gathered in a problem, like in a lab. So let's do a practice problem. This is a practice problem. Okay. Okay, so I'm going to just make a problem up because I think that's just a better way to go here. Let's say we have the reaction. Remember, this is the Haber-Bosch process. We're going to make ammonia, okay? And if we balance this, this should be pretty quick for you guys. 2 nitrogen, 2 nitrogen, 6 hydrogen. 3 times 2 is 6 hydrogen, okay? Let's say in this process, let's say 5 liters of hydrogen at STP reacts with excess nitrogen with a 75% yield. How many liters of ammonia are actually produced? Because ultimately, if let's say I needed ammonia for fertilizer, this would be good to know how efficient this process would be in case, like, let's say I need like 1,000 liters and my process is only 75% yield. You could figure that out ultimately. So let's just work through this. So again, 5 liters of H2 reacts with excess nitrogen. So I want to know how many liters of ammonia are actually produced. So let's start by doing our theoretical yield. So I've got hydrogen. What's the conversion from liters to moles? 22.4 liters is 1 mole. And this is of hydrogen. And if I convert moles of hydrogen to moles of ammonia, and then I can convert moles of ammonia to liters, I can figure out what 5 liters of hydrogen would produce. Okay, so you get 3.33 liters of ammonia that's produced. If you have a 75% yield, 0.75 is the decimal form of the percent. Your theoretical yield for ammonia is 3.33 liters, and you need to solve for your actual. So all you have to do is take 0.75 times 3.33 to get your actual, and your actual is 2.5 liters. Hopefully this helps. I gotta stop my video. I'm running out of time.